there's the acceleration. Either way, you get d is equal to 4h. Okay, and then once you know what that is, well, you know that the horizontal distance is 4h, the vertical distance is 4h, so that L, which is the hypotenuse of the triangle, is equal to the square root of 32h squared, or 5.66h. And then the speed of the ball just before it strikes the plane at point 2. Well, my initial potential energy plus my final potential energy gives me my kinetic energy. It falls first, and then it falls again. So mgh, which is my first fall before it strikes the top of the ladder, plus my second fall, I just found out that that was 4h, is equal to 1/2 mv squared. So
how do you think that's 4h? Remember the letter C?
So that 45-degree angle, and realizing what that 45-degree angle does physically to the setup is important. So when you're looking at these AP questions, carefully observe the setup and watch the angles, because the angles are not put in there haphazardly. The AP people put them in there for a reason.
Why would it be 2 mg?
Why would it be 2?
Why wouldn't it be 2
Or
mg?
are you?
It's at the bottom, ready for an answer.
2 mg.
Oh, down here?
Because you just didn't multiply the 1/2.
I've got my first potential energy, which is the dropping until it hit the top of the ladder. And then I've got my second potential energy from the top of the ladder to the floor. So then I've got mgh plus mg times 4h, which would be mg times 5h. Is equal to 1/2 mv squared. Mass is going to cancel, and then solve for phi. Multiply both sides by 2, you get 10gh, and then take the square root. Okay, but again, the reason I picked out these questions of all the hundreds of questions I've got is because they indicate a point that the AP people work hard at times, like the angle here.
I hate the
That I believe is 2002 exam, something like that.
You would just know.
That's how that makes me feel.
This was 2006, I believe. Thin hoop of mass m, radius r, rotational inertia of mr squared. Again, on the sea level exam, you'd have to derive that. For you, they just give it to you. They tell you that's what the moment of inertia is, mr squared, for a solid disk. For a hoop, okay? Is released from rest at the top of the ramp of length L. The ramp makes an angle of theta with respect to the horizontal tabletop. The table is at a height h above the floor. Derive an expression for the acceleration of the center of mass of the hoop as it rolls down the incline. Well, Vf squared is equal to Vo squared plus 2AD. Okay? Vf, okay, from this, okay, I'm just going to use my energy, mgh is equal to 1/2 mv squared. Solve for V. So then that's what Vf is. That's going to be equal to 2A times the distance that it rolled. Solve for A. You get A is equal to G sine theta over 2. So use energy to solve for the final velocity. And then from the final velocity,
Yes.
go back and solve for acceleration.
Well, they basically God. I don't know. It's there.
Now, did you say
They derive an expression for the speed of the center of mass of the hoop when it reaches the bottom of the ramp. Well, my change in potential energy gives me 2 types of energy because it's rolling as it goes. Okay? So, solve for V. You get V is equal to square root of GL sine theta.
False.
Yeah, I just did.
Using just 2 energies, it's not
Are you
using
sure
3
it's not
energies.
close to wrong?
No, it's definitely right.
I guess I could have just
Did you
cited
not
that,
hear what I
couldn't I?
said?
Opposed to wrong. It's very good. It's extremely close to wrong. Actually,
Well,
so
energy
close
is
to wrong.
energy.
It is wrong.
Doesn't matter whether it's,
Hey.
you know, here I'm just breaking my energy up into what's rolling and what's moving translationally. Up here, I just dealt with the translation. So in other words, what I did here was I broke it up, and then I put it back together again in the end. So I actually could have just pulled this down from here.
Oh, yeah.
Narrator.
Narrator. No, you were on tape like 20 seconds. That's what I mean.
Derive an expression for the horizontal distance.
Out of
Again,
40
this
minutes.
is, as I've said all along, they're going to wrap a motion in two-dimension part into some problem on that exam. And here it is on this exam. Okay? As it goes off the table, it goes into motion in two dimensions. Where does it land? Okay. Where it lands on the floor. Because what they want to see, or what they want to make sure that you know how to, that you know, is that the horizontal motion is constant velocity, but the vertical motion is accelerated. That's what they're testing. Do you realize they're two fundamentally different motions? Okay, then suppose the hoop is replaced by a disc, okay? Because the moment of inertia for the disc is less than the moment of inertia for the hoop.
Please pardon this interruption for afternoon announcements.
It's going to be greater.
Come to the JSU. Start the new year off right. Room 30 today at 2:30. Hey Franklin, tomorrow is Spirit Day. Wear your tie-dye clothing to show your support for our sports teams as we prepare for basketball's home showdown against Woodlawn tomorrow night. And we have 2 bus changes today. Bus 5667, the Lamport bus, will be bus 5467. And bus 5475, Academy, will be bus 5576.
And that's business class.